In this segment, we're going to talk about some of the ideas from machine learning, which is a discipline that powers a lot of the current systems that do natural language processing. So the core idea behind machine learning, as it's applied to NLP, is that we know that as humans, we're really good at understanding language. When I say things to you, you know what I'm talking about, and you can do all these types of comprehension tasks that are very hard for computers to do. So can we somehow teach them to do things in the same way that humans do? So let's return to our example that we had about Siri, and let's think about what it might take to build this system ourselves. So what I have here is a little block of code written in Java. If you don't know Java, that's okay. We're going to talk through this, and it's going to look very similar to what this code would look like in Python or another language. So we start off by reading some kind of user input into this string called user_str. And then we're going to have this big if-else chain. And if the string starts with set a timer, like you ask about setting a timer for 5 minutes or something like that, we're going to pretend that we just have this method start timer dialog that's going to, help us kind of figure out the parameters of the timer and things like that. And otherwise, we're going to check if user string starts with one of two things: set an alarm or wake me up. And in both of those cases, we're going to start an alarm dialog. And then so on and so forth, we might have a bunch of different things that this system can do. The problem is that it becomes very, very hard to enumerate all the different ways that you might ask for a timer or an alarm. What if you ask, please set a timer, or I want to wake up at, right? Now suddenly the system is going to fail. And so even for these relatively narrow things, right, you might think, okay, how many ways are there really for talking about timers? It turns out there's a lot of them, and you're going to have a really hard time listing them out in these big if statements. So it's too hard to list all of these cases here. And the important thing is that we don't have to. I'm going to show you now a system called Cleverbot. You can go to cleverbot.com and play around with this if you'd like. What you could do is type in a question here, and I typed in, what kind of movies do you like? And Cleverbot responds with something reasonable. I like horror movies. Cleverbot wrote this back to me. And the reason it can do that is because it has a big database of all the ways that humans responded to the question, what kind of movies do you like? And so it knows that someone in the past said, I like horror movies in response to that question, and it was able to echo that response back to me when I asked this question. So this is sort of a trick, right? Like we avoid having to hard code in something about, oh, okay, how do I respond to the user when they ask me about movies? We instead just use this big database of information that we already have. So I want to use this as an example of how machine learning works. So we normally think of programming, and programming as you're learning it, as the following. You have some kind of input, and then you as the programmer are trying to write a program to take that input and produce some sort of output. Machine learning is going to work a little bit differently. We are going to take examples of the input and the output that we want to see. And we are going to use machine learning then to automatically construct a program to do it. So for example, in this Cleverbot thing, we saw examples of humans having dialogues, and the learning here was really just memorizing how those dialogues go, and then the program allows us to echo things that humans have said in the past, and it was much more effective than this trying to write down all these if-else statements. Let me show you another example, which is a very popular problem in natural language processing called sentiment analysis. So what that means is, suppose we have something like a movie review. We want to be able to automatically, using the machine, determine whether this movie review is positive or negative, or maybe how many stars the reviewer would give this movie review. Maybe they didn't include a star rating, but we just generally want to know whether they liked it or not. So people build systems like the following. You take data from Rotten Tomatoes, which I know it has percentages and not star ratings, but let's assume it has star ratings. And then we learn a program that looks like this. This is something that the computer can learn automatically. So it'll start off by looking at the review and computing two numbers. The number of good words in the review, things like great, emotional, terrific, etc. And also bad words, maybe boring, uninspiring, things like that. And then it has this logic: if number of good words is greater than 3 and number of bad words is less than 2, we return 4 stars. Otherwise, if the number of good words is greater than 2 and the number of bad words is less than 3, so it's a kind of weaker criterion, we return 3 stars, etc. Now, this is just an example. But the cool thing is that we don't have to write this program ourselves. We can automatically learn to generate this, and this is a technique called a decision tree, because it's making decisions in this tree of if-else statements. So again, we are able to take this data about what we want to do and map that to a program and learn that automatically. That's the general idea behind machine learning, and there are a lot of different models that get used. Things like decision trees, neural networks, Bayes networks. These are all examples of models for machine learning that will produce these programs for you automatically. We're going to talk about something a little bit different. We are going to build a probabilistic model for this language modeling task, which I've talked about before and I'm going to talk about next. And the nice thing about this is it won't require a ton of math to build. Some of these things require a lot of ideas from calculus and things like that, and we're going to see something that can be done with sort of a little bit more easily. So that's where we're going next, and that's the end of this segment.
Awesome. The mic is clear.